All right, so lesson 1-8, page 29. We talked on the end of last week about histograms. Who remembers what makes it a histogram versus a general bar graph? Hayden?
Is it a histogram? It doesn't list out, if there's different presentations in every city, it doesn't list out every name of the city and how far it is.
Right.
It has 5, 6, 7.
Yeah, what do we call those at the bottom? Ava, you remember? Intervals, yes. So it uses intervals at the bottom to make our bars instead of listing out, like you said, every single city that was listed. That would make a giant bar graph. And so we make it a little more condensed, a little more simple to build, simple to read, and to get a better overall picture of our information that we have. So today we're going to be talking about the different data distributions and where our different measures of center would be falling on a histogram. So if we look at number 1, it says to describe the shape of the graph, where do most of the data points lie? Are they spread out or clumped together? So looking at our histogram here, what do you think? What can you describe that as? Izzy?
They're kind of slumped together.
They're kind of clumped together, yeah, in the middle there. What kind of shape do you see? Or what can you imagine that as? Hayden? A mountain, yeah. Kind of starts small on both sides and goes up to a peak. Izzy?
Maybe like a city.
A city, yeah. Kind of looks like some skyscrapers lined up together. In math and in statistics, they call it what we call a bell curve. So a bell curve is imagining it being like a bell, you know, that you can hold and ring like that. So they call this a bell curve. And once you get into higher mathematics, you'll work in that more. So we can say that they are clumped together in the middle. Most of them fall in the middle range. I'm not going to use full sentences on this because we're kind of short on space. So I'm just going to say clumped together in middle, comma, make a mountain or bell shape. And then number 2 says, based on the graph, describe what you know about the birth weights of babies and what you do not know. So if we look at all the pieces on this graph, we have titles, we have labels, we have intervals, and we have the actual bars themselves. Who can give me some things that we know from reading this graph, or something that we can't tell from just looking at this graph? What do we know or not know? Hayden, give me one.
We know how many babies lay between each
Yeah, in the intervals. So we know how many babies fell in that each interval. So yeah, we can put that. I'm just gonna put a little dash for a bullet point there. We can say how many babies weighed the same amount, and then I'm going to put in parentheses intervals. What else do we know or not know from looking at that graph? Izzy?
You know the average of babies that weigh 7.5 to 8.0?
Okay. do we actually know the average? Think about what we have to do to find the actual average. What do we have to be able to do, Izzy?
You have to add up all the numbers and divide it.
Right, we have to add up all the numbers and divide it by how many there are. We have intervals of 7.5 to 8.0. Do we know how many of those babies were 7.5, 7.6, 7.7, and so on? No. So can we actually add them up and divide on this? No. We don't know the actual average, but because of that distribution, we can assume that it's probably somewhere in there, right? If most of the weights fell in that area, then most likely our average is going to be somewhere in that area, right? But we don't know the exact average. So that's something we can put on our do not know side, actually. We could say we don't know exact average. What else can we see on that graph? Don't think too hard, just look at it in general and see what could you tell me about this information by just looking at the graph. Maddie? Okay. They're technically not going by fives, they're going by 5/10 because it's 5.5 to 6. So it is jumping a 5 every time, but it's not like 5 to 10. It's 5.5 to 6, 6 to 6.5. So it is going up by 5/10 every time, which would be the same as a half of a pound. What else do we see? Think about what we said about our distribution here. We know up at top we said that they're all clumped in the middle to make like a mountain or bell shape. So what does that also tell us, Carter? What else do we notice about the shape then?
There's more in the middle than the rest of the thing.
Yeah, so from 5.5 to 6.5, there's a less, and from 8.5 to 10, there's less, right? So the middle is that clumped up area where most of the data points have fallen. So we could say not many babies fall in 5.5 to 6.5 or 8.5 to 10. Let's look at the title there. Birth weights of 30 babies born October 21st, 2000. What don't we know from that title? Birth weights of 30 babies. What's usually the first thing people want to know about a baby that's born? Eva? Huh? Yeah, whether it's a boy or girl. Do we know genders based on this graph? No, just says 30 babies. So we don't know if more of the boy babies are heavier or more of the girl babies are heavier or vice versa. So we don't know of those 30 babies, how many were boys, how many were girls. So we can just say how many boys versus girls. could be all 30 girls or all 30 boys. We have no idea. So we can see from our information here that a histogram, while it can give us a good overall picture, there's some of those details in there that we can't quite get from just having the histogram. If we had the list, like when we had the president's ages or the basketball players' heights, if we had that list, then we could find the exact average. But since we don't have the actual list, we just know that most of our data points is kind of clumped here in these three intervals. So most likely our mean is going to fall somewhere in there. All right, and number 3, explain why the histogram about birth weights might have this shape. What can we say about the information that we gathered that made that be that shape? It's actually it's kind of like a trick question. It's almost too obvious. Don't think too hard. Why would it be shaped like that? Carter? Right, Emma?
Because more babies weigh from 6.5 to 9.0 to 9.5.
Yeah, it's pretty simple, right? That the most babies fell between 7 and 8.5 pounds, and very few were in those outer, either very less or a lot more. So most of them fell in this interval, and very few fell on these outer intervals of the much less or much more. So we can just say most babies, and this is a possessive plural, so plural, and then add your apostrophe on the outside. Most babies' weights fell between 7.0 and 8.5 pounds. And the abbreviation for pounds is LBS. And then very few weighed much less or much more. And once you have that written, you can close it. We're going to do a page together that is typically used as a home link, but we're going to do it together in class, and then you'll have a different practice page with measures of center. Yes, Izzy?